Hi viewers, in our last video we discussed about rational numbers between two rational numbers and representation of rational numbers on number line and comparison of rational numbers we discussed, right? And in this video we are going to discuss about decimal expansion of real numbers. Decimal expansion of real numbers means types of decimal expansions. Okay, let's start the class. See children, to get the decimal expansion of real numbers, for example, as the real number I am taking rational number, as real number I am taking a rational number. Okay, to get the decimal expansion of a rational number, we had to divide the numerator by denominator, right? We had to divide the numerator by denominator. And on this division process, there are two things can happen. One, remainder becomes 0 and remainder never becomes 0, right? There are only two cases. When we divide a numerator by denominator, just we have only two cases. One is remainder becomes 0 and second one remainder never becomes 0. Okay, let's take one example which gives remainder 0. Okay, 7 by 8. One example I have taken 7 by 8. Here we have to divide the numerator by the denominator. Okay, let's do the division process here. See children, this 7 is not divisible by 8, so that I am taking 0 point, so I got 0 here. Next, 8 8s are 64, right? 70 minus 64 is equal to 6. 6 is not divisible, so that point I have taken 0 here. Next, 8 7s are 56. 60 minus 56 is 4 here. Not divisible, so that there is point we have taken, so that we can take 0 here. Next, 8 5s are 40. 40 minus 40, 0. The value of this 7 by 8, I got 0.875. The value of this 7 by 8, I got 0.875. See children, here we got the remainder 0. So that decimal expansion of this 7 by 8, decimal expansion of this 7 by 8 has been ended. Decimal expansion of the 7 by 8 has been terminated here. Got my point? So that the decimal expansion of 7 by 8, that is 0.875, can be known as terminating decimal. Can be known as terminating decimal. I am repeating. See children, here we got the remainder 0. Here we got the remainder 0. Remainder became 0 here. We got remainder 0, so that the decimal expansion has been ended. So the decimal expansion has been terminated. So that the decimal expansion of 7 by 8, that is 0.875, can be known as terminating decimal. Can be known as terminating decimal. It is terminating decimal. Okay. Now, I got terminating decimal. Okay. See children, actually this 7 by 8 given a terminating decimal because we got remainder 0. Actually this case is remainder becomes 0, right? Remainder becomes 0. And we have one more case, that is remainder never becomes 0. Remainder never becomes 0. These two are about P by Q form, right? These two are about rational numbers. Okay. Remainder never becomes 0 here. Okay, let's take one example which will not give remainder 0. I am taking 5 by 6. 5 by 6. Let's divide numerator 5 by 6 here. Okay. 5 is not divisible by 6, so that I have to take 0 point. Yes, I have taken 0 point. I have taken. Next, 6 8s are 48. 6 8s are 48. 50 minus 48 is 2 here. 2 is not divisible by 6, so that by using this point I can take 0 here. Okay. Next, 6 3s are 18. 20 minus 18, 2. Same. Remainder I got same. So I am taking one more 0. Now 6 3s are 18. And next 20 minus 18, 2, 0. Next 6 3s are 18. And next I got remainder 2 only. Means this 3 is repeating here, right? 3 is repeating. And see children, here the decimal expansion is not being ended. The decimal expansion of this 5 by 6 is not being terminated. because we are not getting remainder 0. because we are not getting remainder 0, so that the decimal expansion is not being terminated. Here the decimal expansion is not terminated, but it is repeated. The decimal expansion is not terminated, but it is repeated, so that this type of decimal expansion can be known as non-terminating repeating decimal. Non-terminating repeating decimal expansion. Non-terminating repeating decimal expansion. Let's repeat. See children, here I didn't get the remainder 0. I am not getting remainder 0, so that the decimal expansion is not terminated. So that the decimal expansion is not terminated, but it is repeated, so that this type of decimal expansion can be known as non-terminating repeating or recurring decimal. Now we got the decimal expansion of rational number. One is terminating and one is non-terminating repeating or recurring. Okay, decimal expansion of a rational number. Decimal expansion of a rational number is terminating and non-terminating repeating. Actually, we are discussing decimal expansion of real numbers, right? Decimal expansion of real numbers. Now we discuss decimal expansion of rational numbers. Now, what is the decimal expansion of irrational numbers? What is the decimal expansion of irrational numbers, which is adverse, which is reverse to the rational numbers? What is the decimal expansion of irrational numbers, which is reverse to the decimal expansion of rational numbers? Why I am saying reverse? Because the numbers which are not rationals are irrationals. The numbers which are not rationals are irrational. So that now I want the decimal expansion which is opposite to the decimal expansion of rational numbers. Okay, see here, opposite we want, right? Okay, what is the opposite word of terminating? Opposite word of terminating is non-terminating. Non-terminating. Good. Actually, non-terminating is also there in the rational number decimal expansion, right? So whatever the opposite word we had to get from here only. Repeating, non-repeating. This non-terminating, non-repeating is adverse to the decimal expansion of terminating and non-terminating repeating. Yes. So what are the numbers which gives non-terminating, non-repeating decimal expansion? Those are irrational numbers. So what are the irrational numbers which gives non-terminating, non-repeating decimal expansions? Example, root 2, root 3, root 5, pi. These are the examples which gives non-terminating, non-repeating decimal expansions. Got my point? Terminating decimal is a rational number. Non-terminating repeating decimal is a rational number. Non-terminating, non-repeating decimal is irrational number. Irrational numbers decimal expansion is non-terminating, non-repeating. Now we can define the rational numbers and irrational numbers like this. A number whose decimal expansion is terminating and non-terminating repeating is rational. A number whose decimal expansion is terminating and non-terminating repeating is rational. And a number whose decimal expansion is non-terminating, non-repeating is irrational. Got my point? Okay, let's revise the decimal expansions. Okay, let's revise the decimal expansions. Actually, we have two types of decimal expansions. One is finite decimal expansion. One is infinite decimal expansion. One is finite decimal expansion, one is infinite. Actually, finite decimal expansion can be known as terminating decimal expansion. Infinite decimal expansion can be known as non-terminating decimal expansion. Non-terminating decimal expansion. In this non-terminating decimal expansion, we have two more types here. One is non-terminating repeating. Non-terminating repeating. And one is non-terminating, non-repeating or recurring. Got my point? We have two types of decimal expansion. One is terminating and another is non-terminating. In this non-terminating, we have two more types. Those are non-terminating repeating and non-terminating non-repeating. Okay, terminating decimal expansion is of rational number. Non-terminating repeating is of rational number. Non-terminating non-repeating is of irrational number. Is of irrational number. Non-terminating non-repeating is of irrational numbers. So that a number whose decimal expansion is terminating and non-terminating repeating is rational, and a number whose decimal expansion is non-terminating non-repeating is irrational. What my point? These are the types of decimal expansion. Now let's discuss about pure recurring decimal, mixed recurring decimal. Pure recurring decimal and mixed recurring decimal. Let's see pure recurring decimal. Pure recurring decimal. So what are pure recurring decimals? A decimal in which all the digits in the decimal part, a decimal in which all the digits in the decimal part are repeated. A decimal in which all the digits in the decimal part are repeated is called as pure recurring decimals. Pure recurring decimals. Examples: 2.3 bar, 2.83 bar, 2.9 bar, 2.14257 bar. These all are the types. These all are the decimals which are examples of pure recurring decimals. See here, if you could observe the digits in the decimal parts, all the digits are repeating here. 3 is repeating, 83 is repeating, 9 is repeating, 14257 is repeating. Means all the digits in the decimal part are repeating. Next, we have mixed recurring decimal. Mixed recurring decimal. Mixed recurring decimal. A decimal in which one of the digits after the decimal point is non-repeated and some are repeated is called mixed recurring decimal. I am repeating, a decimal in which one of the digits after the decimal point is non-repeated and some of the digits repeated, some are repeated, is called as mixed recurring decimals. Example: 4.834 bar. Here 83 is not repeating, but 4 is going to be repeated. And one more example: 0.38 bar. There is bar for 84. Here 3 is not being repeated. 84 is going to be repeated. Means in these decimals we have the digits which are repeating, which are not repeating. So that these types of decimal expansions can be known as mixed recurring decimals. Hope you understood about today's decimal expansions. Thank you so much. Bye.